Hi everyone, just going to be starting in a minute, give us a second. Okay, let's get this stream started. Hi everyone, welcome. So, yeah, just a couple of you here so far. I expect some more to be joining us shortly. But yeah, I just thought I'd do some surface mount soldering today. It's for this tiny little PCB. It fits inside a shoe or inside some trainers. Of course I don't have any handy, which is very annoying, otherwise I would show you. But yeah, essentially we have some of those cheap LED light up shoes, but I needed them to be fully controllable for a show that I'm working on called Choreography with choreographer Tim Casson. And during the performance the dancers' shoes light up and in time with the music. So I needed to figure out a way to get the shoes from being passive kind of electronics gear to be actually fully controllable through radio. And the way that I'm doing that is through some brilliant Adafruit feather prototyping boards. You can get these ones, which, I mean, I don't know if you've seen the Adafruit feather line, but I've recently discovered them and I absolutely love them. They're all this kind of form factor, pretty small, but the great thing about them is that they have battery charging capabilities built in, so you can add a LiPo battery and charge it through USB. So yeah, it's just really, really nice boards, and you can get so many different ones with different CPUs on, also different add-ons. Like this one is a radio feather. It's got 433 megahertz radio mounted on it, so that's what I'm using it for. There are a few other radio boards you can get, but I kind of figured that 433 would probably be the best for going through humans and not getting affected by the Wi-Fi. Yeah, but the space that I have inside a shoe is tiny. In fact, I've got here some of the original electronics that are in the shoes, and they're here, right? So they're really small. So you've just got the tiniest amount of space inside the shoe. You can see that these units, I've got a battery inside, and they're filled with resin for protection. So obviously anything I made would have to be just as robust as that. And they've got these wires coming out, so I've got to recreate this whole thing, except make it controllable over radio. So that was my challenge, and I did in fact do it. So I've got the first version. In fact, let me just find the original version. 1 second. Okay, I've just come back from a show, so I'm having to find all the stuff in my cases. Can't find it right now. Oh, here we go. Right, so, don't know if you can hear any of that. I'm shouting from the other room, sorry. So these are the versions that I made, version 1. And you can see that I recreated essentially what was in the shoe already. Here we are, here's a good one. So I've got the feather inside, plus also a PCB and a battery, and these are the original connectors on the shoes. So, and then I had to do the same thing, made a 3D printed case, filled it all with resin, so it should be hopefully pretty robust. But there's a few problems with this version. Well, what did I do? Well, I made a few changes to it which I had to incorporate on the board. A few things like I couldn't get to the reset pin on the feather board, so if anything went wrong I'd have to reset it. I couldn't do that very easily, so I had to drill a little hole in through there just so I could get to the reset button. Also, I decided to switch from using the battery to power the lights to using the 3.3 volt regulator on the feather to power the shoe lights. And that's possibly a bad idea, but I kind of figured that the LEDs in the shoes, they only draw about maybe 100 or 200 milliamps. They're not really power hungry, so I'm hoping the 3.3 volt regulator could handle that, and certainly for short bursts it's been absolutely fine so far, so I think I was probably onto a winner there. But because obviously that voltage is a lot more constant than the battery output, yeah, that made a lot more sense. I'm just trying to remember what other bits and pieces I did to that to sort of hack it to work. So this is very much a prototype and it's working fine. These wire connections have been a bit of a fragile point. Obviously inside the shoes they get very wet and sweaty, humid. And these get moved around and bent around a lot, and I was actually just using the original wires from the original units like these. I'd just cut them off and put them in here, but I think that was probably a mistake because the wires are pretty cheap and nasty. So and I've managed to find myself a few of these connectors, so I can even basically remake the original connector. So what have I done differently in the new board? Well, it turns out, let me just explain these wirings, because there are two outputs from this. One of them, this one, drives the LEDs. So there's a common voltage and then red, green and blue, not necessarily in that order. I'm not sure which order it is, we'll figure it out later. So these go into the LEDs in the shoes, and there's a connector the opposite side of this for inside the shoes. And then this one is 4 cables coming in through a USB socket on the side of the shoe, which is like this. It's got a USB socket, a little micro USB socket which you can power it up from, and it also has a button. So in the original version of this circuit, there's like 2 lines for the button and 2 lines for power. Now it turns out that all of the new shoes that we've been buying have only had 2 lines for this. So here's one of the new buttons. There, the USB input and a button, and there's actually only 2 wires going into the shoe. So it's like, well, how did you get USB power and that button through the 2 cables? So that was a little bit of a challenge I had to figure out. Let me see if I can find I actually took one apart so you can see it. If you hold on a second, I'll see if I can find that. It might be useful. Can I find it? No, I've tidied everything away, so I can't find anything, of course. Well, I can explain what it was if I can't show you. So the 2 lines would be going to power and ground on the USB input like normal, like you'd expect. But when you push the button, it actually connects the power and the ground together with a 100 ohm resistor in. So we had to kind of figure out how to work with that wiring, and maybe I can talk a bit about that later. But here's the original circuit on the original shoes. There you can see it's quite a bit simpler, just a few surface mount components, primarily just for getting a very low level signal from the output pins through a MOSFET or a transistor in order to give enough current to power the LEDs over here. And basically all the other components are just resistors. A resistor into the transistor and a resistor on the other side to limit the current for the LEDs. This new one is a little bit more complicated. We've got all of those things, 3 resistors, 3 transistors, 3 resistors to power the LEDs like before. But this time I also have a couple of diodes and a couple of resistors. These I believe are pull-up resistors, and they manage the circuitry for being able to detect whether this button is pressed or not, and I can possibly show you the circuit diagram for that later. Anyway, I expect you want to just see soldering really. That's what live streams are for, so I'll probably just get to starting to solder these boards. So yeah, with any surface mount soldering, you should probably, the best way to do it is by using solder paste and sticking it in a reflow oven. But just for sort of prototypes and testing, you can actually do surface mount soldering manually with an ordinary soldering iron. I also have some of these magnifying glasses as well. Let's see if I can widen that out. So I use these to see what I'm actually doing. That's really helpful. And apart from that, you just need a whole load of flux, an ordinary solder, and a lot of patience. I also have a lot of tweezers like this. So let's just see what happens, I guess. It can be very fiddly to handle these tiny components. What should I start with? I should probably go right. Oh, what should I do? Left to right, I suppose. Let's do these resistors and transistors first. So these resistors are just 1K resistors. They're just they're current limiting resistors for the transistors. And these are current limiting resistors for the LEDs. I'm not honestly sure. In the original board with the original shoes, I did lots of tests to figure those out. I'm not quite sure what they should be in the new shoes. I might just guess it for now and see how that works in terms of colour balance. Yeah, we'll see how that works out. But this is the whole new bit with the diodes and pull-up resistors to test these new switches. So that's the bit I'm most concerned about, whether it works. Okay, I'm just going to quickly check to see if there's any comments. How do I see that? I think they appear here. Can someone send me a comment? Make sure I'm seeing those okay. Nice. Oh, you can hear me there? Hang on. Right. Okay, cool. No comments so far. That's good, but we seem to be streaming right. Okay, good. Excellent. Welcome everyone. Okay, let's start with soldering some of these. These are 1K resistors. So I've got a book. You might have noticed my book of surface mount resistors. These are very cheap from China. You can just get books full of them for sort of small projects. They're absolutely fine. These, I believe, are 0805. That's not the tiniest resistors that you can get. I've also got some 0603s, which are even tinier. I mean, they're like dust. I mean, these ones are pretty small. I need a bunch of 1K resistors or thereabouts. Let's have a look. Here we are. Got all the 1Ks. Let's get those out. That's the first one. These three here I'm going to solder. Let's just zoom back in. You want to get really close, I assume. Focus. Come on, focus. Is it focusing? Is that too close to focus? There you go. Alright, excellent. Get the glasses on. Right, so first thing I'm going to do is use some solder flux. I quite like these pens. They're very cheap. Well, they're not that cheap. I think they're maybe 10 quid or something. Just put a bit of flux on there. It just helps a little bit. How do I do this? It's been a little while since I've done it, so I've kind of forgotten the techniques that I've used, but essentially I think it's good to get a little bit of solder on some of the pads first. I'm right-handed. I'm just going to clean this. Let's have a look. Right, so maybe if I just tin these pads a tiny amount. I do sometimes do this with solder paste as well, and then just flow it with a soldering iron. That's actually quite a lot of solder. Might have some trouble with that, eh? My resistors are here. Be careful not to lose them. You can't actually see them where you are. Just going to unpeel those. Get 3 out. Tip them out onto the desk. Try not to lose them. Right, let's see what happens. See if I've messed this up. I might have put too much solder on, but let's start. This is where a steady hand comes in. So I'm just going to not solder on that side, push it down, probably should have just put solder on one pad, that might have been sensible. And then put some solder on this side. I would normally move this around a bit more. Can you see, is my head in the way? I don't know, let me know if my head's in the way. I can't really see what the video feed and this at the same time. Just gonna... Okay, so it's not very flat, that's the problem that I've encountered. Just left my meter on. That's because I put solder on both pads. I should have just put solder on one pad. There you go. I seem to have rescued it. Excellent. So I wonder if I can do that. I've just had a momentary panic when I realised that I couldn't find my resistors. They're here. But yeah, I think possibly what I can do is melt both these sides. Or yeah, I really definitely shouldn't have put solder on both pads, because what I've got is these like kicking up a little bit on one side, which is really dumb. Lesson learned. I think I'd know by now. There you go. And number 3, I'll turn my meter off. I like to make sure all my resistors are facing the right way. Obviously there's no right and wrong way. I guess I like to make sure that all the resistors are facing the same way. It's funny how they buck up sometimes. Oh, I'm not doing very well here, am I? Let's see if I can get that on both pads. To heat them both up. Oh, it's very frustrating that they're not straight. Okay, well I've messed those up pretty badly. Should be totally fine. But I've learned my lesson. So yeah, I think last time I did this I actually used solder paste. I think I can still do it with normal solder. I just think I need to put the component, I just need to put the solder on one pad and then fix the component down by that one pad before doing the other pad, so that was my mistake. Obviously when you're doing it with solder paste you can paste up all the pads and just squidge the component onto the board and the solder paste kind of holds it. I just thought for this little test, for this first board, oh jeez, I'd do it by hand. So I giggled just then because I'm undoing these transistors out of their packet and I just happened to flick it and one of the transistors went flying up in the air. So now I have to find a bit of tiny component. Oh, thankfully I found it. There it is. So tiny. Okay, so let's just do one solder pad on these transistors. Do that one, do the end one. Yeah. Okay, good. Okay, and usually I'd probably use a smaller tip as well for that sort of thing. That's fine. Right. So, teeny tiny transistors. I'm just trying to pick it up nicely with my tweezers in a way that's helpful. There you go, I've got that there. Oh, it's at quite an awkward angle actually. I don't want to move it though because then I've got the camera view all nicely lined up. So I'm making my life more difficult so that you can see it better. Hope you appreciate that. Okay. So now I'm thinking if I just make this top pad melt, there you go. So then I can just, I guess I should be careful not to overheat these components. I think they're quite fragile. Let's get all of the transistors on in that way, and then I'll do the other legs all in one go. Again, I'm just trying to pick it up. My tweezers, here we are. Oh, I must admit, although it's difficult, I really do enjoy doing this kind of detail work. What's that? Is that close? Oh. There you go. One more transistor. Again, just trying to pick it up with the tweezers. Good times. It's so difficult. And I guess it's just about finding an orientation for the transistor that makes it easy to hold with your left hand and solder with your right hand. Well, I guess you could do it the other way. Pretty good. Oh, excellent. Okay, so now I can just freely solder all the others. I might just quickly send a tweet to let people know this is still happening. Right, there you go. Just send a tweet, so hopefully a couple more people might join us. And let's solder the other legs on that transistor. Right, probably want to put a bit of flux. Oh, that's tons of flux. It's really leaked out of this pen. Can clean that off later though. Oh, blimey, it's just flux everywhere, which probably means I can just put a bit of solder on the iron. I really should be using a smaller tip. That should just go on the pad. Did it go? I think it went a little bit. Doesn't seem to be going on onto the board very easily. Let's try it this way. There you go. There, perfect. Excellent. That's the transistors and the first 3 resistors done. Okay, next up, I guess I can do the diodes. I hear that these diodes can be a bit fragile, so I should probably be a bit careful with them. Now, where did I put them? Are they here? Yeah, these look like diodes. I'm not sure I got the footprint entirely right. I kind of just used a general footprint in my PCB design. So yeah, I wasn't working from an actual diode. Let's have a look, and these are Schottky diodes. So yeah, hopefully with this circuit layout, I can tell not only if the button is pushed, but also if the unit is being charged by USB, and that was a limitation of the original one, so I couldn't detect when a charger was put in or not. Okay, let's add a couple of bits more here. Right, so that's one side. Now that is, just got to check that I line up the little lines. around on these components. Okay. This is where it's quite awkward from this angle. But you know, I can't be bothered to move the camera, so oh. Not bad. Other diode. Let's have a look. Seems pretty good. So now I'll just solder the other sides. Might need a bit of flux here. Yeah, it's not going down very easily. Oh, this is really loaded up with flux this time. Often you have to push it down to get the flux to flow out, but it seems really super loaded. There you go, that's better. It's flowing a bit better now. Perfect. Alright, excellent. Oh, how are we doing? Well, that's those. So then I've got these resistors, which I believe are both pull-up resistors for that diode circuitry, and I believe they need to be quite high resistance, I think like 68k or something, just to counter the internal pull-ups inside of the feather. In my tests I used 46k. Yeah, that's probably closer. Alright, let's have a look to see what I've got in terms of surface mount around that sort of level. I've got some 51s and 68s. I'll try the 68s, I think. Just because you can never be too sure what the internal pull-ups on a board are going to be. Okay. Two of those, just emptying them out. Try not to lose them. Excellent. Right, same deal as before, I think. Although I might do it on this side so I can get around to the other side a bit more easily. I guess I could also put some flux on the resistors. That might help it flow on. But it seems okay. That's alright. Let's do the other side. Yeah, if you're watching, could you just let me know that sound is alright, that you can see okay? I can't really see or hear what I'm doing, so that'd be really helpful. Okay, last couple there. There you go, that's most of it. Right, so let's just have a quick look to see what those current limiting resistors there were before going to the LEDs. Right, I'm going to check my notes. So it looks like they were between 3 and 9 ohms. I might just try some in between for now. Let's try some 6 ohms, something like that. I've got 5.1. Let's do 6.8. Let's start with 6.8, and then I can check to see what the white balance is like on these final 3. Right, yeah, so let's just try that. And also, because I'm not sure of the wiring on the new shoes. So, and this is a prototype board. This isn't going to make it into production. This is just for me. So I'm not too worried about any of it. Okay. .68 ohms, marked as 6R8 on these. Not bad. Oh, detail work. I love it. Excellent. So it's funny, look how much better these are than these 3. So even just doing all of this once, I've improved quite dramatically. Okay, other side. Got that soldering completely the wrong place. Didn't put any flats down this time. It seems to be going on okay. Excellent. So that is all of the components done. So what's left? Well, I need to put some pin headers down either side to go onto the feather, although to be honest I'll probably just put them straight onto a breadboard for now and connect them to the feather through a breadboard for testing. These 2 are where a battery goes. And these tiny batteries I've got. Let's zoom out a bit. Yeah, one of these tiny batteries. I've got lots of these. I've got a few different shapes and sizes. Some are flatter than others. The thing to watch out with these batteries is when you get them from random places. Come on, focus. There you go. When you get them from random places, they tend to have different polarity on the connectors, and I've blown up quite a few feathers that way. It's pretty frustrating. So probably shouldn't put that battery on yet. I probably do need to connect some of these here. Should I put the pin headers on first? Let's put the pin headers on. Why not? Why not? So this requires a slightly different setup. First of all, let's get some pin headers. Breadboard. Now. Great. Thanks, Dave. And hi, Techchrome. Thanks for the feedback. I'm glad it's all working. Oh, what am I getting? Pin headers. If there's any questions, let me know. It's a good time for questions. Here we are. So I need a 4 and an 8. Stick it on a breadboard to hold it straight. Now I'm going to put a bit of flux down, just all gets a bit easier with some flux. And this flux pen is super fluxy at the moment. And if you use flux, I mean I'm sure you know, but when you use flux to do pin headers, the soldering can just get so fast because you just basically barely need to touch them. Let's see, well, I normally do one on each end first, just to make sure that the pin headers are on straight. That's good. And same on this side. On each end. And while I'm here, I might as well do these two. And on the other side. Excellent. So, next thing to do would be to clean off all the flux. Let's get a toothbrush, some isopropyl alcohol. Basically all I do is just over a bin, just to stop the drips. Can you see that? You probably can't see that. There you go. Just give it a little scrape. Get all the spare flux off, get it nice clean. There we are. So that's the final board, pretty much mostly finished and ready for testing. So the only bit I have to do now is do some connectors. I've got to solder the battery on this side, solder the connectors on this side. Although I've got 4 on that side, it's actually I'm only using 2. I just also added button input and output just in case I wanted to use some of the older style connectors. And on this side is for the LEDs. Oh no, it's the other way around. This is the USB and switch, and these are the LEDs. Question from TechRoom: how did I get into this line of work? Well, that's a very complex question. I don't know if there's an easy answer. Let's think of the short version. I used to just be a kind of programmer, games programmer, but in the last few years I've been doing more and more hardware. I started with Arduino, basic Arduino stuff, and then more and more of my projects started having electronic elements to it. And the first really complex thing I did, I suppose, was laser light synths, so I learnt an awful lot on that project. It got really complex. But yeah, and then at that point you realise I just love designing PCBs. Like before that, when you're using all this sort of breadboard stuff, I really hate using that stuff. So now I'd rather spend time on my PC, on my Mac, designing PCBs than just wait for that to get in focus, than messing around with stripboard. Yeah. But yeah, so it's just doing more and more of that stuff really, and over the years you just get better. There's loads of good YouTube stuff as well, actually. Loads of good electronics on YouTube. It's really helpful. So there you go, all soldered up. I suppose I might as well carry on here really with the other stuff. What do I need to do? I guess it's the connectors. I need to go and get some shoes. Can you give me a couple of minutes? Don't go away. I will be back. Actually, I could write a little message. Come on, I've got some text now. Check this out. How do I change it? Oh. There you go. How professional is that? Alright, I'll be right back. Okay, I'm back. Let's have a look. Right, I can get rid of that overlay. So, let's zoom out. Oh, that's good, isn't it? Tidy up my workspace a little. Put away all of the SMD components in their right places. Right, so this is 6.8 ohms. Always put them back where they came from. This is 68K. And these are the diodes. I'm going to leave the diodes out for, I suppose I should put them away. No, I'll leave them out. They go in the other case. Right. Oh, loads of crap left. Right. Too much rubbish lying around. Oh dear. So, let's have a look at the shoes. So, here we are. Here are the shoes. I've got a few. Just going to turn the soldering iron off for a moment. I got loads. Like, the shoes are actually the cheapest part of this whole thing. I think you can get a pair for like £10 or something like that. Shipped from China, of course. They're very cheap, but then, you know, these are kind of the cheapest, most throwaway part of this whole project, really. Because they are so cheap, so cheap. So, and of course, like, once I've got the electronics, I can put them then into any of these shoes. I'm going to take the laces out because they're a little bit easier to work with without the laces. Ah, Techrum, you saw me speak at Frontiers. 2011, was that when I was doing all the mobile phone stuff? Yeah, so I had this project called Pixel Phones, where I could sync up all the phones in the audience. And it's funny because there's a direct lineage between that project and this one. So this project's called Choreocracy, and it's an interactive dance project. So working very closely with choreographer Tim Casson and 3 incredible dancers, Joe, Hannah and Chloe. And yeah, and the whole show is controlled through mobile phones. So the audience get to choose what the dancers do in real time and vote on what happens next. So there's a very direct lineage between what I'm doing now and what I was doing then with the mobile phones. It's funny because I don't think back then I was really doing much electronics stuff. Let me show you how these shoes work at the moment, just from China. You push the button and you can cycle through the colours, red, green, blue, and then that's supposed to be yellow. It doesn't look very yellow. That's supposed to be cyan, magenta, and then that's meant to be white. See how blue it is? The blue's really strong in these shoes. Then a couple of flashing options, really super annoying. Ooh, nice. And then back to off eventually. And here's the little button that I mentioned in there, and there's a tiny switch in there. Let's pull out the insides, because this is what we're replacing. Oh, goodness. So there you can see inside the shoe, this is what I have to work with. That's the original electronics in there. And so that's got to come out. And you can see the two connectors there. One with 2 wires, that's for the USB and power, and one with 4 wires, and that's for the LEDs. Let's take this out. So, that's the original power stuff. Now, for this prototype, normally I would probably remake some of these, but for this prototype, I think, what should I do? Tell you what, I'm gonna remake these with some longer cables, just so that, because I'm gonna be testing this on a breadboard, I want the wires to be able to get into the shoe from here. So let's do that. Bit boring because you're going to see me doing crimping. But yeah, it took me quite a while to figure out what these connectors were. They're sort of flat. They're really, really flat. Come on, focus. There you go. They're really, really super flat. They're much flatter than normal JST connectors. Like on the original shoes, I'd have these connectors to work with, much more common JST type. But yeah, these are all really super flat, and it took me a while to identify them. I'm just trying to remember what they were called. I think they were a type of Molex connector, but just a different style. Let's get that shoe out of the way. So I need a 2-pin, what is it? I need a 4-pin male or plug and a 2-pin socket. Okay, so these are just, well, what is that? That's the sockets, and these are the plugs. And I need a 2-pin. That's a 2-pin socket, I believe. That's a 4-pin plug. It's of course the opposite from what I need. That's a 4-pin plug and a 4-pin socket and a 2-pin plug. That's what I need, right? I've forgotten already. It's not, is it? It's a 4-pin plug, 2-pin socket. But that's the right housing, and so is that. Okay. Oh, brilliant. Okay, so I need some wires. What wire should I use? That's a good question. I need something strong, because these get messed around quite a bit. What have I got in terms of wires? Let's have a look. You know what I might use? I've got some like ribbon cable. It's a bit annoying because there can be some weird tensions on it, but for this I think it's the right thing, because this is a prototype. It's not going to end up in a shoe. It doesn't matter. So, some ribbon cable. I need a section of 4 and a section of 2. So, and this is actually 1, 2, 3, 4, 5, 6. Perfect. How long? It's probably this length. Looks alright, doesn't it? Yeah, I'll probably do it. Peel off the 2. Like that. Okay, so then it comes to really boring crimping. Ugh, crimping is so boring. But crimp connectors are cool. So we put up with them. Here's my crimp tool. Here is some wire strippers. So these wire strippers are the vice grip ones. I ordered them in from America. and they're pretty cool. I find them a bit bulky though, but they're quite good. They just basically do what they need to do. You don't even really need to think about it. They can do a couple at a time. There you go. Really super easy. Just trim those off a bit. Like that. So that's going to go in my crimps. And just remind myself the 2-pin one is a socket. So I need a couple of socket crimps. So yeah, I find this is really helpful if you use my magnifying glasses, especially because I'm getting to that age now where I'm getting a bit short-sighted. So stick that in there. So I think that might be a bit, is that a bit big, that one? I'm just not sure which of these slots to use. I'll figure it out. Maybe I'll try using the smaller one, because it's quite a small crimp. Okay. That's where I realised that I should have peeled these apart a little bit. There you go. Don't know if you can see that. Push it through till you can see it just on the other side. I can't actually see it. There it is. There you go. I can't tell if it's in focus because I've got my glasses on. It's not in focus. Come on, there you go. You can see that. Pretty nice crimp. Okay, then the other side. So there you go. Excellent. So, which way up? Probably that way. Okay. There you go, right, so we've got those two crimped, and get one of the plastic mounts for it. So a message from Adam Davis. Seb, I recreated your Neon Cat idea, if you recall, worked really well. Loving your new work. Thanks, Adam, that's very kind of you to say. So yeah, Neon Cat, back relating to what Techroom said, with the Frontiers conference in 2011 and a big interactive mobile phone project, ridiculously complex project. And one of the things I did was make a little game. Now this doesn't look right at all, there you go. I made a little game. Now if you remember at the time, Nyan Cat was kind of a thing. Oh my goodness, that's real. That was a while ago, huh? Nyan Cat was a thing, and I've made a little game where Nyan Cat flew around from phone to phone and you had to catch it. Yeah, ridiculous. There you go, that's good. So that's the 2-pin one. So now the other side I need to do 4-pin plugs. So Adam, what was your version of it? Did you do a similar thing with, probably with Node.js, I would think. Sensible way to do any phone things. Back then I was using C++. Now I still do use C++ a lot for all of my work, for all of my laser control work. But for using, like, for WebSocket stuff, Node.js is just really easy and brilliant. Oh, it's just not happening now, is it? Oh. Maybe it's because I'm trying to do 4 at once. Oh, it usually works fine. I wonder if there's something stuck in it. Try the other end, otherwise I might have to use some ordinary strippers. How strange, only seems to be doing half of it. Okay, well, got there in the end. More or less. It's a bit messy. Okay, I guess probably if it's better if I work down here, then we can make sure that it's mostly in focus. Yeah, Node.js from Adam. First time playing around sockets. Managed to get a little proof of concept in a couple of hours yet. That's very cool. Yeah, Node.js is pretty straightforward, I think. I like it. Don't get to do a great deal of JavaScript. Choreography project is JavaScript, mostly, except for the bits that control the lasers and the bits that control the shoes. But other than that, it's Node.js. Yeah, super easy for doing WebSocket stuff. Okay. Don't know if you can hear my computer whirring away in the background because of the streaming, I think. Oh, I hate stripping wires. Just stripping a little bit more off here to get them in line with the others. Okay, so I need plugs. Here we are. Oh, you realised you can't see that. Just pulling these pins out of their pick and place slots. Oh, there you go. Let's see that now. So more crimping is in my future. Not bad. Sorry if you came here for service mount soldering and all you're doing is watching me do crimps. But I thought I might as well leave it streaming while I do the testing. I expect you're all wanting to see the shoe lighting up, maybe. We might even get there today, who knows? That's worth sticking around for, surely. Okay. Oh, come on. trouble threading that one through. There you go. How's that look? My camera's upside down, so it's really hard to frame stuff. Come on, get in focus. Come on. Oh, stupid camera. Come on, there you go. There you go. Figured it out. That's my finished crimps. Not bad. Okay, let's get it in the housing. This one. So the thing I'm not sure about is the wiring, the new wiring on these new shoes for these LEDs. Whether the power, the common power line is the same place that I've got the common power line on this circuit board. And obviously the individual LEDs don't matter so much because I can change the resistors on the board and change the software to accommodate that. But the main power line needs to match up, so I should probably just check that the power line on the shoes is the same as the power line on my board, or at least it's like the leftmost or rightmost. I should try and figure that out. I'm just going to pull that through a little. Sometimes these don't always go in that easily. There you go. I do that with all of them. There we are. Excellent. Okay, so how do I figure out whether I've got the same line as they do? Well, there's the one I just pulled out. Is it this one? I guess... oh, actually, you know what? I can just about make out, unusually, because these are all sealed in resin, but unusually, I can actually make out some little labels on the inside of the board. I don't know if you can see them. Let's have that. Can you see? Oh yeah. See, it's just in the copper. Can you see it says BGR? So then presumably the other one says, let's have a look. What does it say? BGR, and then, oh, it says B+. I don't know why it says B+. Presumably it's shared voltage for all of the three, and then these two are also marked plus and minus, so that's really helpful. So I'm going to mark the connectors with a red pen, just so I know which side is positive. And I should probably do the same on the shoe connectors as well. So just double check which way around that is. There. Brilliant. Oh, there's no clay. Some of the wires inside the shoes are literally been like sewn into the soles. It's really annoying. Really hard to work with. I don't know if you can see there, like that wire is going under all of this sewing. I don't think it's stitched in this. Oh yeah, it is. I think maybe, oh maybe it's not stitched in, but it's certainly glued in under there on its way up to the side, and that button. Really awkward and annoying. Alright, well at least I've marked those connectors. So now I've done that, there I've got red paint all over me. Now I've done that, I can mark these ones that I've made up the same so I can be sure to wire them the right way around. Literally just put my pen down and I've lost it immediately. There it is. There you go. Right, so now I can be sure I can solder those to my board and I can be sure that they are the right way around. In fact, I might just follow that wire all the way down. Mark that. Same with this. Never hurts to mark your positive side. Great. Okay, where are we at? So I guess I can solder this on now. It's quite interesting. One of the faults that we had on the other boards were, like you can see on the original connectors, like they're quite thin, they're quite close to the edge, and they'd always just sort of break at their insulation position. So I don't quite know what to do here. I've given them quite a long pad. I'm a bit worried the pads are a bit close together. Oh, do you remember earlier as well I said I couldn't get to the reset pin? Well, what I've done on these boards is actually break out the reset pin to here. And I've broken out ground to there. So if you want to reset the board, you should just be able to connect those two sides with, I don't know, probably even some pliers or something would do it, right? So that should be good. Obviously once it's all in resin, like you can see this one, it's all in resin, it's really difficult to get to. Probably not going to use resin next time. I've actually got some quite stiff 2-part silicone material that I'm going to try embedding it into this time. But I think I'm going to try soldering these wires just a bit further along towards the end, and then you can make sure there's some glue or some other sort of adhesion onto there to try and avoid it breaking on the edge quite so much. So let's do that, I suppose. What's this? This is the LEDs. I'll tell you what, I'm going to get my normal glasses for this part. Right, there we are. Sorry, they're in the other room. Okay, so it's going to be a little while, I think, before we can see any shoes lighting up, but let's see how far we get. Okay, so this is this side, and USB plus is there, so the red on the outside. Let's see, I wonder what the best way to do this is. Yeah, I'm just never quite sure the best way to get a really solid connection. I'm thinking probably tinning the cables is a good idea. Oh, you just never know with tinning though, do you? Because sometimes it makes a weak joint at the point between where it's tinned and where it isn't tinned. Let's do it anyway. Let's tin it anyway. So Dave has given me some suggestions. Thanks, Dave. put drill holes close to the edge of each pad and feed the wires through those and solder quite a way in on the bottom side to give it more support. That's a good idea. And if you notice on the original board, I did have drill holes quite close to the edge, not really super close though. Come on, get in focus. Get in focus. There you go. You can see there are drill holes there on the original board, not massively close to the edge. But the problem I had with that is that if you look at the feather, you can see that, well, essentially this board is mounted on top of that, and because of this USB connector here, and in fact loads of things there, so no matter which side of this board I put it on, I would end up like hitting this USB connector. So the new version that I've got, I had to deliberately leave out holes, just use pads, because this version is sitting on top of the feather. Let's see if I've got a feather that I can demonstrate. I can't now that I've got pins all the way through it. But this would sit on there and sandwich right up against that. I have to be really close to that. So I've had to completely clear the bottom side of any contacts at all, because they just get shorted out by that USB connector. You can see on this version, on the original one, I'd cover this with silicone. Come on, get in focus. I'd cover this with silicone just to stop that shorting. So I don't know, there's no good answer, is there? But I was hoping if I just put these contacts as close to the edge as possible, get as much insulation on over the edge as well, and just a bit of glue, or make sure that that's enclosed also in the silicone. Hopefully it might be enough, but we'll see, eh? We'll see how it goes. I mean, essentially I've got the toughest job you can imagine, because these electronics are literally being jumped around on. It's probably, well, I think any wearable project is a challenge, but I think for shoes in particular, because it's not just the flexing that you get, but it's also the impact. I suppose I do have the benefit though that it's they're not used, they're not used for the entire show, they're just put on at the final bit where for a nice finale. Okay, let's see if I can do a bit of soldering this way. I was inspired to do soldering this way by Big Clive. I assume you all follow Big Clive on YouTube. If you don't, I would highly recommend him. He is really interesting and loves taking apart fun bits of electronics. So what should I do? Let's zoom in a bit. So what I'm going to try and do is, if you can see that, I'm going to try and get as much of the insulation over as possible and just solder this sort of final bit there on the pad. Let's see. Oh, of course, I hate it when the insulation doesn't quite match up. Right, let's just snip those a bit. Of course, yeah, the cost of this is quite high, and actually it's the shoes themselves that are probably the cheapest part. So I think I mentioned they're probably £10, £15 for a pair, something like that. The feathers themselves I think are $25 in American. And the batteries are such a pain, because you can only order 2 at a time, because there's sort of regulations in delivery. So the batteries are quite cheap, but they're just so expensive to get, because you have to pay for there's a couple of UK suppliers, but you have to pay for DPD courier, and you can only buy 2 at a time, so you end up spending maybe £5 on batteries and then another £6 on delivery, so it's really frustrating. Just going to put some blobs of solder on there carefully. And also, what I should do is I'm going to flux these leads, these cables. just so they absorb the solder well. Right, again a bit awkward because I don't want to move the camera. I don't want to move my board. Right, so hopefully if I just touch this, I'm going to get my magnifying glasses. Hopefully if I just touch this, it should flow into the cable and all be perfect. Just about see it past my thumb, can't you? Oh, oh. Could possibly do with a bit more solder, but that's pretty good. I think that might do it. So I'm just going to add a bit of solder on this side. Oh, that loosened the cable a bit, so that was a bit of a mistake. So the problem with these kind of ribbon cables is the plastic melts pretty quick. I think that might be okay. I'm not at all happy with this solder though, hang on. Of course, be careful touching cables while you're soldering, they get very hot. That might just do it. What do you think? Oh, it's a bit of a mess on camera, doesn't it? Just because all the insulation sort of melts on these, it's not great insulation. But I think that might be okay, especially if I seal all of this in resin. Hopefully it'll be alright. Can I do a shaped slot thicker at the edge to grab the insulation? Then a plated through slot at the end. Solder the wire actually inside the board thickness. Yeah, possibly. I mean, I don't have a ton of room to work with. I think this is probably going to be okay. I'm not sure that we get much, like what you're suggesting, if I get it right, is that by putting some of the wire through the board, you get some extra structural integrity, and I'm sure that's probably true. But that wasn't where the wires were breaking. The wires were breaking at the edge of the insulation and the solder joint. So it wasn't actually the solder joint that was failing, it was sort of this area there. And obviously, if you can imagine, when that was sort of coming outside of this board, that was wiggling around a bit, plus all the moisture which was corroding the cheap wires that I was reusing from the Chinese shoes. But I think this might be okay, because I can seal all of this around with extra silicone. Well, we'll soon find out, eh, Dave? Let's see how it works. How it works out. Okay, so now the same deal with the other side. Oh, this is kind of tedious. I hate this sort of crimping and wiring bits. The surface mount soldering bit is actually probably the easiest part, isn't it? Compared to all of this nonsense, which is just tedious. With all of my electronics projects, I find that just connecting wires together is the most boring part. Right? And it's never that easy either, so it's not only boring, but it's also kind of a bit tricky. Sorry, I know you can't see what I'm doing there. I'm just actually stripping these wires. I'm going to do the same thing again. Tin it. Tin wires. Probably going to flux them this. Did I flux them last time? Not sure. And again, using the Big Clive method of soldering. If it ever gets in focus with my hand, let's see what happens. Sorry, I know it's frustrating when the focus isn't on. This flux doesn't seem to be really doing much. There we are. Excellent. So voltage on that side. I wonder what I'd quite like to do. Just somehow hold these wires in place while I'm soldering them. They just need to be spread out a little bit. Get that out of the way. That way, does that look? Looks okay. Okay, add a tiny bit of solder to the pads. Maybe if I just flood the whole place with flux, that might be good. Yeah, I think that's good. Oh, so much flux, probably too much. Can you have too much flux? Probably. See what happens, eh? Now. Oh, that's good. That one's good. Last one. Okay, so again, I mean, I just really I should learn by now not to use ribbon cable. The insulation is just really awful. I hate it. It melts horribly. But I don't know, see how this looks on camera. Come on. I should switch it to manual focus, shouldn't I? There you go. So you can see the insulation is going over the edge of the board, but you can also see where the insulation has sort of failed a little bit, where it's got a bit hot. But I kind of think if I enclose that in enough glue or material around the edge, that we'll be okay. Or I don't know. It's worth a try. Let's see how it works. Okay, so let's test this board. Now I need to find some breadboard, some bigger breadboard. Bear with me a moment. Just getting some bigger breadboard, hold on. There we are, that's what I want. That's the one I want. But yeah, I think I should probably get some slightly better cable for the actual shoes than this ribbon cable. I just think ribbon cable is probably not really designed to withstand a great deal of heat. Okay, so how do I test this board? I don't want to attach it to a feather yet. I do want to just sort of plug voltage into it and make sure all the transistors are working and that we can get the LEDs to light up. So let's do that. So I need a feather with some pins on it for testing with. Oh, I'm so terrible. My workspace just gets really messy really quickly. Very upsetting. So I lose all of what I'm trying to work on. ugh. Okay. Here's a feather with some pins on. Excellent. So what I can do is kind of just, yeah, I can do, no, all the pins are broken off this one. Am I going to need to solder up a feather? I think I am. I think I'm going to have to solder up a feather. Got some new ones. So let's do that. So yeah, I was running through the cost of the materials. So yeah, the batteries tended to be the most expensive part. The feather's about $25. You know, I guess the PCBs are relatively cheap to get made. I think it was, I tend to use Seed Studio, which I like them a lot. Seed Studio in China, of course, and they have a nice PCB fabbing setup. And it takes usually a week or two to come over from China. It should be this way around. Well, let's just push it into the board to solder it. Yeah. So I think I probably spent something like $50 to get maybe 20 of these boards made up. There we are. You can see them here. If you wonder why I'm having trouble putting things on the camera, it's because the preview that I'm seeing here is upside down. So it's very confusing. Yeah, so that wasn't too expensive. So yeah, I think probably the feathers are the most expensive part. Okay, solder them up. Just getting this wire out of the way. Oh, I'm just thinking, what could I do? That's probably alright. Now I'm just going to put some flux on this to make it a bit faster. I can wash all this flux off after. I should do. Some flux can be corrosive over time. I think this is a fairly harmless one though. I've got it says no clean flux, so it's probably alright, but still, I'm not going to risk it. You don't want the flux all over your board, do you? Oh, I didn't put flux on this side. Well, why isn't that flowing so well? It's because there's no flux. Okay, great. So, that's ready to test. I'm just going to give it a quick clean. I'll give both of them a quick clean. Can't get it out. Genius. Nice work, Seb. Just get a bit of isopropyl alcohol, give it a quick squirt, get it all over my hands. Sure, that's not great for me. So, how am I going to test this? Well, what's the minimum on this board? I need to give it probably 3 volts and ground, and then I should be able to just make the outputs go high or low to test those parts. Which way around that? Okay, this way. Okay, so that's the same way around, but let's just take out 3 volts and ground, put it into there. I'm just having a think, because I think I might have put the pins on this the wrong way around, because I think it needs to go down. I think it needs to be upside down. That can't be right, can it? Oh no, it is this way up, yeah. So it just goes like that, literally sits on top of there. Confuse me for a moment. Okay. So let's hook up 3 volts and ground. I'm just going to use the feathers power connections. It's white and black. White is 3 volts, black is ground. So I think, hopefully, if I hook that up, in fact I could just do it straight into there, couldn't I? So it's literally, I think, look, I've got a red and brown one here, let's use that. Red 3 volts, brown ground. I'm just going to pass that directly over to 3 volts and ground here. Okay, so I think then if I know, you know what, I am going to put them in there. I'm going to put them in here so it's easier for me then to pull up various pins to test them. I can plug in a shoe. Oh my goodness, are we nearly ready to get some shoes lit up? That's ridiculously exciting if it is. I'm just a bit worried about those 2 pads touching. I might just do a quick continuity test, see if they're shorting. No, they seem okay. Okay. Alright. Looks okay. I suppose this is just for testing, isn't it, this one? So I shouldn't worry so much. Okay. So, plug that in to some power. I have some lying around somewhere. Here we are. That looks good. Okay, good. I've got some power. So, I think I just need to pull those pins up to make them go, to make the lights come on. Well, let's see. Let's see if that's going to work. Hopefully. Oh my goodness, I'm quite nervous. Oh, there you go. Excellent. Alright. So, blue, green, red. Excellent. Oh, I'm so pleased. That's good. That was kind of what all I was worried about. I suppose it'd be good if I could finish this whole thing up. And what's the time? Oh, it's 1:30, it's lunchtime. But we have the shoes at least lighting up, at least the transistor part of this circuit is good. So next up we need to test the diode part of the circuit. and then actually mount it on a feather and get that working. But I think I'm going to stop the stream for lunch. Thank you so much for joining me. I hope it's been interesting. Yeah, and maybe I'll stream the rest of the build later. Alright, see you later. Have a good lunch.